All right, hello. So here, hang on, let me get this up, is what we're gonna do. For this video, we are gonna watch, this is a review of double-digit multiplication, but what we are going to be doing is a different type of way to solve besides the regular algorithm. So first what I want us to do is you should have a notebook and a pencil to take down the notes and solve the problems as we go along. And then if you're ever confused, rewatch the video or rewind a little bit and see if it makes more sense if you listen to it a second time. But first, I just want to quickly review on your notebooks. Draw, I know we talked about this a couple days ago, an array showing 3 times 6. So if you remember what that means, right now on your paper, draw an array that looks like that. And obviously, array is something that we have done typically when we first learn how to multiply, and it is kind of like an organized visual of multiplication. So if I were going to do 3 times 6, I would know that I have maybe like 3 rows and there's 6 in each row. So there's 1, 2, 3, 2, 3, 4, 5, 6. And that these are in rows and columns. And sometimes I even like box it just to see. And I have 3 going down and I have 1, 2, 3, 4, 5, 6 going across. Now when you first learned how to multiply, you would count all the individual ones. Or you could skip count and say like 3, 6, 9, 12, 15, 18. Or you could count by 6 and say 6, 12, 18. Regardless, you would solve and figure out that the answer is 18. Now, there's a reason that we're reviewing this, and it's because in a minute we are going to go over some more challenging problems. So now I want you to show an array, draw an array showing 23 times 3. Now, assuming that you're kind of like, this seems like annoying, that's like a bigger number, you are correct. But I still want you to do it and just show me what happens when you do 23 times 3. So I might do 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23. Okay, and I need 3 down. And then I could fill it in. And I know this is a pain. That's the reason I'm kind of making you doing it, is to show you that as we get into these bigger numbers, drawing an array becomes less likely to happen because nobody has time to do this. At this point, it would probably be easier just to add 23 3 times, but this would be an array that's visually showing 23 times 3. Okay? So you could solve that. Obviously, we would not count those little things, but we could, if you were really little and didn't understand, you could skip count by 3s all the way up, or you could skip count by 23s. But this is showing that 23, I should have 69 little dots in that area. Now, I'm going to add another layer, and if I told you to draw an array of 28 times 16, I'm hoping you are thinking she's got to be crazy, because that would take us forever, because we would have to do 28 dots going this way, 16 dots going down, and then fill the whole thing in. And that is obviously not something that we are going to do. So now that we are in 4th grade and these are the types of problems that we are going to be doing, we are going to solve it, instead of calling it an array, we are going to solve this problem using something called an area model. Okay? Now I'm hoping that we're remembering that what area means from 3rd grade. So if I have an array, so let's do 3. I'm going to do this. 3 going down, 4 going across. I'm hoping that we realize that in order to solve how many little dots are there, we can multiply rather than adding each of them. Because if I have 3 down and 4 across, I'm repeating addition, but I can instead just do 3 times 4 equals 12. And that realistically, in 3rd grade, you should have learned that if I have a square and I want to figure out how much is inside of that, and I have 3 inches by 4 inches, I can just do 3 times 4 equals 12 inches squared. And the reason is when we do area is we are actually seeing how many squares we can fit inside there, which goes along with an array. So we're going to transition, because this is such a big problem, to something like this. Okay? And at first you might be like, oh, what is that? I promise you, I'm actually going to go back, I think. We're going to break this problem up. So before, I'm going to go back to this and show you that when I do 28 by 16, I'm going to make a rectangle. I actually might switch it. What do they do? Okay. I'm going to make this side over here. This side is going to be 16. And I'm going to make the top let me redo that so I don't do that line. The top is going to be 28. Now, I'm hoping you're like, oh, that makes sense because if you notice, this horizontal line is longer than this vertical line. And so it makes sense that this would be 28 because it's longer and 16 is a shorter number. Now, what you're used to doing is an array, which would be filling on all of those little dots, which we are not going to do. Instead, we are going to look at it like an area problem. Now I'm going to break apart these problems because at this point we have not learned how to solve a problem like this. So we cannot solve it that way. We are coming up with another more visual way of solving this problem. So what I do is you can take whatever number. I usually take this number on top or the bigger number and I break that apart. So if I have 16 times 28, I want to pick one number to break apart. I'm going to break apart this 28 and I'm going to break it. The 2 I know is really 20 and the 8 I know is really 8. So I'm going to split that up just into 20 and 8. Now, I'm hoping that we're realizing that I'm not going to make this side 20 and this side 8 because they're the same size and 20 is much bigger than 8. So what I'm going to do, if this whole problem is 28, I'm going to use a different color marker. I'm going to say that like maybe that is 8 right here, and then maybe this is 20 right here, and I'm going to break apart this problem into a more manageable, easier piece, okay? So after I've broken that part up, I'm noticing that now this is a problem that I can solve. I could solve 16 times 20 if I ignore this piece right here, right now, and only worry about this big rectangle. I can solve and figure out what goes inside that rectangle because I have 16, I'm imagining 16 dots going down and 20 dots going across and filling it in, which I'm not going to do. And we have learned how to solve 16 times 20 because the other day, or yesterday, you should have learned that you, again, can take apart this 20. And I could really do 16 times 2 first and get that to be 32. And then I can multiply it by that 10, which is in that 20. And I could get 320, meaning that inside that box is 320. Then I can come over to this rectangle, and this is a problem I can do. Now, as a reminder, if this line is 16, then this line is also 16, and I see that this is 8. Well, I already know how to solve 16 times 8, and if I don't know 8 times 6, I can skip count, but 8 times 6 is 48, so I'm going to put down my 8, regroup my 4. 8 times 1 is 8, plus 4 is 12, and I get 128 is inside of that box. Now, if I have 320 in one box and 120 in the other box, and I want to solve the whole problem, I'm going to put those two together. So as of right now, if I'm looking at my original problem, which was 28 times 16, I broke this up into 2 steps. I first did 20 times 16 and got 320. Then I did 16 times 8 and got 128. And if you look, I've done my 16, I did 20 times, and then I did 8 times, and then I have 2 answers. So I'm hoping that you're realizing that I have to put my 2 answers together. So my third step is I'm going to take my wholes, my 320 plus my 128, and add them up, and I get 448. Okay? Now, one second, I'm going to grab something. If, when you're doing these, when we start working on these and it helps you to check on a calculator, that can be something that you do. So I'm going to just quickly check 28 times 16 in my calculator, and I do get 448. Now, if you are like, what in the world did you just do? I'm super confused. That's okay. We're going to keep practicing. And the reason is that you being able to draw an area model is showing that you actually understand multiplication. Here's a much more obviously organized one. They broke this up a little bit differently. They have this whole thing up here is 28. This whole thing is 16. And then do you see how they split it right here? They made this the 8, and they made this the 20. But as you know, 20 plus 8 is 28, which is the whole thing. They did 16 times 8 in here and 16 times 20 in here, and they would have gotten the same answer. We're going to try another one. This one is 32 times 24. Again, you're probably like, what is that thing that they have? It's okay. No worries, we're going to go through it. So it's 32 times 24. At this point, we have not learned how to solve this algorithm. So instead, we are going to try to fill this out in here. Now, I always stop and look, and I'm noticing that this is a rectangle, and I'm noticing that there's two sides. So I have this side, and I have this side down here, okay? Now, one side is going to be 32, and one is going to be 24. I am hoping that we are like, ooh, this side is bigger than this side, so this side has to be 32, and this bottom part has to be 24, okay? Now let's look at some other things that we can fill out. I'm noticing that they broke apart this little piece here and this other piece right here. I know that if this line is 24, then this whole line is 24. But it looks like they're breaking up 24 into two pieces. If I have the number 24, I know that the 2 is really 20 and the 4 is really 4 ones. So I could break it into 20 and 4. I'm hoping that we aren't thinking that the 20 is this and the 4 is this, because look at how much smaller this is compared to this. I would have to switch them. So I'm going to make this the 4 and this the 20, okay? Now I've made that into an easier problem. So what I'm going to do first is I'm going to solve, if you see this arrow, I'm going to figure out what goes inside here. That means I need to take how long it is, which is this 32, times how wide this little piece is, which is 4, because that is an area model or like a simpler array. And I can first do my 32 times the 4 ones. If I solve 32 times 4, 4 times 2 is 8, 3 times 4 is 12, I see that inside this piece is 128. Okay, so I've done 32 times this 4 already. Now I'm hoping that we're realizing that I still have that 20 left over. So again, I'm seeing that this whole line right here is 32, but now I'm multiplying it by that 20. So this time I am really doing 32 times 20. As a reminder, we have learned how to break that problem up. You could solve it in, you could do 32 times 2 times 10, or you could do 32 times 10 times 2. It doesn't matter what you do, but you have to break apart that 20. I'm going to make this 20 into 2 times 10, because I know 2 times 10 is 20. 32 times 2 I'm going to solve first. 32, and I can write it on the side, is 64. But then I have to bring down that 10 and multiply that, and I know that that would get me 640. So inside here is 640. Now my last thing is that if I know that this little thing is 128 and this big one is 640, I need to put them together and get my whole, because I have two parts and I'm trying to find the whole, and I get 768. And that must mean that 32 times 24 is 768. And I'm just going to check on my calculator because I also make mistakes, and I just want to make sure that I did get the correct answer, and I did. As you can see, these are a lot of work, but this is showing that you conceptually understand multiplication. I'm going to pause. I want you to pause this one, and I want you to see if you can figure out any of the things that would go on this area model. Maybe if you're like, I feel super confident, you could actually solve it. If you are like, oh, what is happening? Then maybe try it, and once you start feeling like you're getting very confused, press play and listen to me solve. Okay, we are doing 19 times 22. Now, if I'm looking at this, I'm noticing that 19 is the smaller number and 22 is bigger. If I'm looking at this area model, I think that this is the smaller of the two lines. So then I'm going to make this side 19, and then I'm going to make this side 22. Okay? Now, what I have to do is I need to break apart that number, because as a reminder, I don't know how to solve 19 times 22 like that. So I need to break apart that number. Looking at this area model, it looks like this side is being broken up, and I know the whole thing is 22, but they're breaking it apart. I'm going to break up 22 into 20 and 2, and I'm hoping that we're realizing that this is the 2, and this is the 20. So look, 20 plus 2, 22, 22. If this side's 19, this line's 19, and this line's 19, okay? Now I'm going to break this part up, and I'm going to find this little piece first. I want to figure out what is inside here. Well, if it's 19 and the side is 22, I know my first step is going to be to do 19 times 22 to figure out what is inside there. 9 times 2 is 18. 2 times 1 is 2, plus 1 is 3. So then I know inside that little thing is 38. Now I'm getting on the trickier side. I just solved this really big problem. And I'm realizing that this is 20. And I'm noticing that this line is 19, or this line is 19. So I'm multiplying it by 19. Again, I don't know how to do that, but I could split this problem up. And instead, I could do 19 times 2 times 10. Because again, 2 times 10 is that's 20. I'm just breaking it up and making it easier. I'm going to first do 19 times 2. 9 times 2 is 18. 2 times 1 is 2, plus 1 is 3. But then I have to remember that times 10, and I get 380. So then I know that inside here is 380. Now, my third and final step is that I've got two parts. I know that this is 380, and I know this is 38. So I need to add them together. 9, 10, 11. And I should get 418. And again, I'm going to try that on my calculator. So I'm going to type in my original problem, 19 times 22, and I get 418. Okay? All right, we're going to try another. This time, though, you are going to try to actually write them yourself, which is extra tricky. I'm going to have you just watch me do it, but can you also write this in your notebook while we go? So our problem is 34 times 65. Don't know how to solve that like this, so I cannot do that. So right now, first, I'm going to make my area model. Now, I'm noticing that 65 is much bigger than 34. So when I make this, I'm going to make it like a rectangle. 65 on top, 34. Okay? And I'm hoping, I'm just going to redo that. I'm hoping that we're realizing that this side is the 34, and this is the 65. So again, there's my 34. And this whole thing is 65, okay? Now I have to break this apart. I'm going to keep my 34 the same, but I'm going to break apart that 65, and I'm noticing that it's 60, and then I have 5 ones. So I'm going to put, you can do whatever side you want. I'm going to put over here my 5, and then this is my 60. So I'm hoping we're seeing that this piece is the 60, and that little piece is 5, because 5 is way less than 60, okay? Now, I actually have to solve, and I need to find out how much is in here, and I need to find out how much is in here. I'm going to start with the smaller problem first, just because I think that's easier. If I know this is 5, I need to figure out how long this line is. Well, if this side of the rectangle is 34, then this side of the rectangle is 34. So my first step is going to be 34 times 5. 5 times 4 is 20, so I'm going to put down my 0, recruit my 2. 5 times 3 is 15, plus 2 is 17. So I am getting 170 for inside that little piece. Now I'm over here, and I need to solve this. So again, I'm seeing that this is 60, and this is 34. So for my step 2, I'm doing 34 times 60. As a reminder, I don't really know how to do that, so I need to break apart and do 34 times. I'm going to take that 6, and I'm going to multiply that by 10, because 60 is really 6 times 10. Now I can actually solve. I'm going to do 34 times 6 first. 6 times 4 is 24. 6 times 3 is 18, plus 2 is 20. But then I can't forget about this times 10, and I know that I have 204, and then a 0 for the tens place, and I have 2,040, which I know goes in here. My final last step is to add all these two numbers together. So I have 2,040 plus my 170, 7, 8, 9, 10, 11, that'll be 2. And then I get 2,210. Let me check that. 34 times 65, oh, hang on, 34 times 65 equals 2,210. Now you guys are going to pause the video, and I want you to try making your own on this next one. So we have 2 more, and then we're going to be done. 22 times 47. Pause it, see if you can draw the area model as far as you get, and then check to see how you are doing. All right, first I'm going to draw. Again, 47 is a lot almost more than double what 22 is. So I'm going to make another rectangle. Okay, I'm not very good at rectangles, that's okay. And I am going to keep my 22, but I'm going to break apart my 47 into 40 and 7. Now, I'm going to keep this side as my 22, and then if that's 22, I also know that that's 22. I can fill that in. And then I'm going to make my bottom part 47. But I decided to break apart 47, so I'm going to put my 7 over on the side. I'm going to make it pretty small because 7's a lot smaller. And then this is going to be my 40. Okay? Now, my first thing that I need to do is I need to figure out how much is in this and how much is in this. So my very first step is going to be, I'm going to solve this one first. So I know if this is 22 and this is 7, I can do 22 times 7 for my area model. 7 times 2 is 14. 7 times 2 is 14 plus 1 is 15. And then I see that this in here is 154. Okay, now I'm going to go to my step 2. And I know that this is 22, and I see that this is 40. So for this, I am doing 22 times 40. As a reminder, I don't know how to do that, so I need to break apart my 40 into 4 and 10, because 4 times 10 is 40. And I'm going to keep my 22. Okay, and first I'm going to do 22 times 4. You could do 22 times 10 first, whatever works for you. I'm going to do 22 times 4, which is 88. And then I need to bring down that 10 and multiply that. And I know that 88 times 10 is 880. And I'm going to put that in here. And then my last step is to actually add these together. And I'm going to take my 880 and my 154. 8, 9, 10, 11, 12, 13, 8, 9, 10. And I'm getting 1,034. And let me check this on the calculator. 22 times 47 equals 1,034. Okay, we have one last problem that I want you to try. This one is 73 times 36. Okay? And when you're ready, you can, after you've tried to solve it, press play and listen to me explain it. If I'm doing 73 times 36, you could decide what to do. You could leave the 73 and you can break apart the 36 into 30 and 6. Or if you wanted to, you could leave the 36 and break apart the 73 into 70 and 3. Either way, it doesn't matter. I'm going to stick with what we've been doing, which has been keeping the first number and then splitting apart the second. So 73 times 36. This time I'm going to put 76. It's almost like I'm making it like this time. Because if this whole side is 73, and I know that this side is 36, 36 is a lot smaller than 73. Okay? If I were going to do it the other way and I decided to make this 36 and make this 73, I could do that. Okay? So then if I were going to break apart my problem, if you did it differently, then just listen and see if you end up getting the same answer in the end. If I'm doing 36 this way, I'm going to break apart 36. That's going to be my 6, and there's my 30. Now I'm going to try to solve. First, I need to figure out what's in here, and then I also need to figure out what's in here. So my step 1 is if this side 6, I know this side is 73. I'm going to do 73 times 6 first. 6 times 3 is 18, regroup the 1. 6 times 7 is 42, plus 1 is 43. So then I know that inside here is 438. My next step is going to be to solve this area model. And again, I'm doing 73 times 30. And I need to chunk this and make it into an easier problem. So I'm going to make this 30 in 3 times 10. So I'm first going to do 73 times 3. 3 times 3 is 9. 3 times 7 is 21. And then I have to do that times 10, which gets me 2,190. Okay, I'm going to put that in here. My final step is to put my 2 area models together, 2,190, and I'm going to add that 438, 8, 9, 10, 11, 12, 4, 5, 6, and I got 2,628. And let me check this one in the calculator. 73 times 36 equals 2,628. Okay? All right, good job, guys. If you have any questions, please don't hesitate to ask. Hopefully this was helpful. and be on the lookout for the next video about how to actually solve these types of problems with the algorithm. Okay, bye.